Okay, so we have this question number 4. Can you read it? An electric field is uniform and in the positive x direction for positive x. Electric field is in the positive x direction for positive x. And uniform with same magnitude, but in the negative x direction for negative x. Negative x means what? Negative x-axis. Positive x means positive x-axis. Okay, it is given that electric field is 200 I cap for x greater than 0. What is meant by x greater than 0? X greater than 0 means x value is positive. Am I correct? Greater than 0 means it is positive, which means it is on the positive side of x-axis. Right. X greater than 0 means it is to the right of the origin. Right of the origin is called x greater than 0. Then what is x less than 0? X less than 0 means it is to the left of the origin. So these regions are described by these inequalities. All right. X greater than 0 means x is positive. That means positive value for x. It is on the right side of the origin. Okay. X less than 0 means it is to the left of the origin. Got it? And they have given the electric fields. X greater than 0 region, electric field is, tell me, electric field is 200 I cap Newton per Coulomb. All right. And x less than 0, electric field is minus 200 I cap Newton per Coulomb. Remember, this minus sign actually goes with the direction, not with this number. The value is still what? Magnitude is 200 and the direction is minus I cap. Okay, here the direction is plus I cap. Here the direction is minus I cap. I'll write it here. Right. So electric field on the left side is where? It is minus 200 I cap Newton per Coulomb. Okay, so I'm going to mark the directions of electric field. Look at this. We always use the green arrow for electric field. Tell me how you draw the electric field. Here it is to the right. How do I conclude that it is to the right? Because it is positive I cap. I say that it is positive I cap. Positive I cap means x-axis. Okay, x-axis is characterized by the unit vector I cap. Okay, how about the left side? Here it is negative I cap. I said the negative goes with this I cap, right? So the direction of electric field here is what? To the left. Am I correct? Am I correct? So unlike in the previous question, where the electric field everywhere was to the right, this question has what? To the right of origin, electric field is rightward. To the left of origin, electric field is leftward. Am I correct? Now let us mark the area vectors. How many surfaces do we have here? I'll draw the area vector. We always represent area vector using yellow arrow. Look at this. For the right surface, area vector is to the right, because we know what? Area vector should be perpendicular to the surface under consideration, right? Okay, so this is my area vector for the right surface. And how about the surface? Area vector is to the left, because area vector has to be perpendicular to the surface, right? Then two more to go. Look at this surface, that curved surface. Where do we draw the area vector? Straight up. Am I correct? That is how I draw the area vector, right? This is area vector. And for the last surface, this one, tell me how you draw the area vector. There also it is perpendicular straight up. Now that is area vector. So I'm left with 4 surfaces here. Look at this. This is the cylinder. This is flat surface number 1. This is curved surface number 2, curved surface number 3, flat surface number 4. Got it? Altogether, how many pieces? One surface area here, one surface area here, one surface area here on the right side of origin, one surface area here on the left side of origin. Got it? Let us name them for convenience, okay? I'm going to name them. Down is not needed, same as up, right? So I'm just naming them. I'm naming this as 1, surface number 1, surface number 2, and this is surface number 3, and this is surface number 4. I got 4 surfaces altogether. I'm going to calculate the flux. There is something else given in the question. Where is the cylinder? A right circular cylinder, let's complete reading. A right circular cylinder of length 20 centimeters and radius 5 centimeters. Look at that. Radius is given 5 centimeters. Radius is 5 centimeters means area is what? Area is pi r square, right? Area of, if you look at the cylinder, the end area is what? Look at the cylinder, the end area of the cylinder is circular, right? End area of a cylinder is circular, right? Pi r square. So it is pi into radius is 5. But it is in centimeters, so you have to convert to meters square. So what do we get now? Pi into 5 square, 25. 10 raised to minus 2 square, 10 raised to minus 4. Okay, keep it there. Let us finally read the question. Question A, what is the net flux through each flat surface? Each flat surface. Question B, what is the flux through the side of the cylinder? Question C, what is the net flux through the cylinder? Question D, what is the net charge inside the cylinder? Okay, let's see one by one. They have given the locations, and left end of the cylinder is at x is equal to minus 10. Right end of the cylinder is at x is equal to plus 10. That is given in the figure. Left end is at minus 10. Right end is at plus 10. So the total length is 20. Right in the middle, we have the origin. Origin is called x is equal to 0. Got it? So let us see the surfaces one by one. What about flux through the first surface? Do you see surface number 1? Do you see surface number 1? This is surface number 1, okay? Surface number 1. Area vector is straight up. Electric field in this region is to the left. Am I correct? Am I correct? Look at the region number 1. This is region number 1. Region number 1. In region number 1, area vector is upward. Electric field is to the left. Area vector is upward. Electric field is to the left. Angle is 90 degree, right? Correct. So flux will be what? Can you tell me? E into A into cos of 90. That is equal to 0. Correct. So flux through the first curved surface is 0. What about second surface? Same thing will repeat. Am I correct? E into A into cos of 90. That is 0. Why? Because look at the right surface. Area vector is upward. Electric field is to the right. Area vector is upward. Electric field is to the right. Angle is 90 degree, right? So flux will be 0 there as well. EA cos 90. Now, how about the third one? Look at the third surface. Third surface. Which is the third one? Third one is this one, right? The right circle, right? Right circle. Tell me how you take it. E into A into cos of 0. Tell me why it is 0. Tell me why it is 0. Because if you look at the right surface, area vector is rightward. Electric field is also rightward. Look at the area vector. The yellow one. Yellow vector is to the right. Green vector is also to the right. Both the electric field and the area vector are in the same direction. Okay, both the electric field and the area vector are in the same direction. So theta will be what? 0. Let us put the electric field value. It is given. What is electric field value? In this region, electric field. Put the number only. When you use this form, do not use the vector sign. Okay. You can take either dot E dot A or EA cos theta form. Here I'll go with EA cos theta form because I know the angles, right? Correct. When you know the angles, you better go for this one. Tell me, E is what? E value is 200. Area is what? I've written over here. 25 pi into 10 raised to minus 4. Cos 0, I don't have to write it is 1, right? Cos 0 is 1. So tell me what you're going to get. 25 into 200 is actually 5,000. 5,000 pi into 10 raised to minus 4. I'm done. 1, 2, 3, 4 places down, you're going to get 0.5 pi. But 0.5 is called 1 by 2, right? So 1 by 2 into pi. What do we get? Pi by 2 Newton per Coulomb into meter square. I got the value of 5.3. Flux on the third surface. Flux on the third surface, right? How about flux on the fourth surface now? Flux on the fourth surface. Right, flux through the fourth surface. This is the fourth surface, right? Look at the number. I've given numbers to all the surfaces, right? 1, 2, 3, 4. Tell me about the fourth surface. E into A into cos of 0. Why? Look at the left surface. Area vector to the left. Electric field is also to the left. Correct. Area vector, the yellow arrow, is leftward. Electric field, the green arrow, leftward. Both are in the same direction, right? Correct. Electric field is to the left. Area vector is to the left. They are parallel to each other. Theta will be 0. What is electric field value? Look at the value, 200. I had told you, never take that number negative. Why? Negative belongs to I cap. Correct. Negative actually is the direction. Negative I cap is the direction. Got it? Right. Negative I cap is the direction. That 200 is the number there, right? When you use this form, you have to use the numbers only, the magnitude. All right. So tell me, this is 200 into area. Left surface is also circular. Area is found there, right? Tell me, 25 pi, tell me, 10 raised to minus 4. Same as before, right? Correct. So that's going to be what? Pi by 2 Newton per Coulomb into meter square. So I'm done with 4 cases. Flux through the curved surface, flux through the curved surface, flux through the flat surface, flux through the flat surface. Now, what is the total flux now? Question C, phi net. Phi net is equal to phi 1 plus phi 2 plus phi 3 plus phi 4. We got phi 1 as 0, phi 2 as 0, phi 3 pi by 2, even phi 4 is pi by 2. So let us just add them up. Tell me 0 plus 0 plus, tell me pi by 2 plus pi by 2. Tell me what you're going to get. Pi by 2 plus pi by 2. Pi Newton per Coulomb into meter square. This is question C. And the last question, like we did before, flux. They are asking about the net charge. Do you remember the statement of Gauss's theorem? Flux is equal to 1 by epsilon 0 into Q. Like the old times. Tell me what? Now they are asking you to find the Q enclosed, charge enclosed inside the cylinder. You can just cross multiply phi into epsilon 0. What is phi value? Net phi value is pi into epsilon 0 is 8.85 into 10 power minus 12. So you consider this as 9. 8.85 is very close to 9. You can do a little bit of approximation. This can be made 3. 9 to 3 is 27. So actual value is 27.8 or something. So it doesn't matter much because look at the power of 10. 12 zeros, no? 12 places. So it is 27 into 10 to the power minus 12 Coulomb. So if you got the concept and if you can draw all this stuff, it is very simple. Understood? Just draw the electric field line. So they have given 2 hints here. Number 1, x greater than 0. X greater than 0 means x is positive. That means it is to the right of the origin. To the right of the origin, electric field is 200 I cap. I cap means it is to the right. Okay. The next less than 0, that place is to the left of origin. Left of origin, electric field is 200 into minus I cap. Minus I cap means it is to the left. Got it? So just know one thing, electric field on the right side is 200. Even electric field on the left side is 200. Only thing is that on the right side, it is to the right. On the left side, it is to the left. That is what they give in the question. Then you are having one surface here, second surface here, third surface here, fourth surface here. These 2 surfaces, flux will be 0. Curved surface flux will be 0. That's common sense because field is in this direction. So will the flux pass through the curved surface? No. Field is passing through this, no, the cylinder. Flux won't come out of the curved surface. Flux on the left surface you can calculate. Flux on the right surface you can calculate separately. And theta value will be 0 in both cases. You find the net flux this way, then find the net charge. Understood this? All of you got it?